Hello students, myself Vikas Tiwari. Once again I welcome you to our YouTube channel Ma World of Physics. Also just I want to convey you information that you can download us from the Play Store with the name Mass Academy Advanced Physics. So today we are going to discuss with the basic concepts of circuit analysis. Okay, circuit analysis, this topic is very important for the students, those who are already studying in the first year in various streams like B.tech or B.sc. Okay, so for that the concepts of circuit analysis are very important to study the basic concepts of further electrical and electronics engineering. So let us start with the concepts of circuit analysis. So first we will go what are the basic concepts of the circuit analysis. In that context we are going to define the 8 things over here. The very first thing is called KVL, that is called Kirchhoff's voltage law. Okay, so that is called Kirchhoff's voltage law. And the second thing is KCL. Okay, and that is called Kirchhoff's current law. Okay, so these are the two things that we have already studied in current electricity in class 12th, but still we are just discuss what is KVL and what is KCL. KVL is called the second law of Kirchhoff and this is KCL is called first law of Kirchhoff's first law. But I am just first I will discuss KVL, then I will discuss KCL regarding that. Okay, and the third one is one more thing that has been introduced now at this particular level, and that is called nodal analysis. Okay, so that is called nodal analysis. Nodal analysis is nothing but it is just the extension of KCL. Okay, so it is the just the extension of KCL. And the fourth thing is that is called mesh analysis. Okay, mesh analysis is nothing but just it is the extension of KVL. Okay, so basically nodal analysis is based on KCL and mesh analysis is based on KVL. After that there are some other important things like that are called current voltage division theorem, voltage division theorem, and next is current division theorem. Okay, so these are very important just to study the concepts of circuit analysis and the application of circuit analysis. So this is voltage division theorem and current division theorem. After that we will discuss concept of open circuit and short circuit. What are the concept of open circuit and short circuit? Okay, so you have already heard the name of short circuit and you have already heard the name of open circuits. Okay, so what are these things that we will going to discuss further? Okay, and the finally eighth thing is that we are going to discuss as a basic concepts of circuit, and these all are the basic concepts of circuit analysis. Okay, and that is the last thing is source transformation. Okay, so that is called source transformation. So these are the particular 8 things which are very necessary if we want to study the basic concepts of circuit analysis further. Okay, so I will discuss one by one all these things. So once again just I am listing you KVL, Kirchhoff's voltage law, KCL, Kirchhoff's current law, nodal analysis. Nodal analysis is just extension of KCL. Mesh analysis, it is just extension of KVL. Voltage division theorem, current division theorem, and concepts of open circuit, short circuit, and finally is the source transformation. Okay, so let us start one by one. So first I am going to take the very first thing that is called KVL. Okay, so what is the KVL? KVL, as already we know, that it is called Kirchhoff's voltage law. So first of all, just I will give the statement. What is the statement part of? Okay, so the statement part of KVL was that in any loop. What is loop? Loop is a closed path. Just I'll elaborate it further, but just at this point I am telling you what is loop. Loop is a closed path. Okay, from where we start and when we will come back, it will become a loop. Okay, so in any loop, algebraic sum of all the voltages is equal to 0. This is the simple definition part of KVL. In any loop, algebraic sum of all the voltages is equal to 0. And if we want to go for mathematically, we will say summation of V is equal to 0. This is the mathematical statement. But how we are going to apply it, that is very important for us. For that particular thing, we should go for a sign convention. Okay, so what is the sign convention that I am going to follow over here, and what that is the thing is, first one is sign convention. Okay, the very first sign convention, if I'll go with that, is while moving in direction of current, while moving in direction of current, voltage drop. When I am talking of voltage drop, okay, I am talking of the word I multiplied by R. Okay, current multiplied by the resistance or impedance of the circuit. For later on we will discuss what is the difference between resistance and impedance, but here I am telling you just in a simple way, voltage drop IR is always taken as negative. Okay, if we are moving in the direction of current, the voltage drop IR is always taken as a negative. Vice versa is also true. Okay, but what I am following is that while moving in the direction of current, voltage drop IR is always taken as negative. Okay, so we can say it's vice versa is also true, but what I am telling you, this is the what I am using throughout this circuit analysis, that while moving in direction of current, voltage drop IR is always taken as negative. And second one is while moving from negative terminal to positive terminal of battery or source, voltage is always taken as positive. Okay, so while moving from negative terminal to positive terminal of battery or source, voltage is always taken as negative. If one wants to take its vice versa, that is also correct. So both the vice versa of both the statement is also true. Okay, but again I am clearing you what the sign convention I am using throughout is that particular sign convention over here. Okay, so now I have just given you what is the statement. Statement is simple: in any loop, algebraic sum of all the voltages is equal to 0. Also, summation of V is all equal to 0. Okay, and the sign convention, this is mathematical part, and sign convention, while moving in direction of current, voltage drop. Voltage drop means I multiplied by R. In simple words, you can say this is Ohm's law, okay, is always taken as negative, okay. And while moving from negative terminal to positive terminal of battery or source, voltage is always taken as positive, okay. So when we will switch from negative terminal to positive terminal, voltage is positive, okay. And again see, dimension wise IR is also voltage, and here is, this is also dimension wise, this is also voltage. That's why it is voltage law. That's why we are taking summation of V is equal to 0. So if we go for a application part of it, just I am taking a very simple example of it, how we are going to apply it, okay. For that, just I am taking two resistances, okay, and a very simple circuit. This is the simplest circuit, okay, in which I am taking two voltage sources, V1 and V2, and two resistances R1 and R2, and just I am telling the current flow of current direction is this one. This is the flow of current direction, okay. So what we are saying, okay, current flows in this particular path, okay. So what we are saying, this is a loop. If we start, how can we can judge? These are the points A, B, C, D. If I move, start from A, and if I will come back to A, though this is closed path, okay. Current also flows in closed path. To flow a current, a closed path is required, okay. Current doesn't flow in open circuits, okay. Now this is the current, this current I flows over here, this current I flows over here, again the current flows over here, but there is no element, okay. If there is no element between 2 points, these are called equipotential points. Therefore potential difference of this point is, these 2 points is 0, okay. So if there is no element between these 2 points, okay, these are called equipotential points. These are also same points, okay. If you want to join like this, you can also join like this, make a ground over here. These are common points, okay. But just to say the circuit is composed like this, therefore we can say these are equipotential points. If these are equipotential points, so potential difference between these 2 points is equal to 0, okay. And again the current will flow over here. So this loop has been completed, okay. Just to apply summation of V, and we will use these two particular sign conventions over here. So I am starting from here, okay. I am standing over here, and current is flowing here. So while moving in direction of current, okay, current starts from here, and in the way it found a resistance R1. So there is a voltage drop. Voltage drop, whenever there is a resistance and current flows through it, resistance, then there is a voltage drop, and it is equal to IR1. And the by sign convention, while moving in direction of current, voltage drop, IR is always taken as negative. So what we are saying, the direction of myself and the direction of current is same. So I will put it here, minus IR1, okay. And if I will move further, okay, sum of all the voltage minus IR1, then plus, okay, just I will reach over here. So again the direction of current and direction of, I will start my journey from here, then I will reach here. So the direction of myself and the direction of current, it is again same. If both are same, so we are saying, and the resistance is in the way of current, so I will say there is a voltage drop IR2, but again from sign convention it is taken as minus IR2, okay, plus another voltage. So we are following this one, summation of V. So this is voltage, again I will reach from here to here. Now when I will switch, I will found first I will switch to positive terminal, and then I will switch to negative terminal. My second sign convention says, while moving from negative terminal to positive terminal of battery or source, if I will switch first from negative terminal, then from positive terminal, voltage is taken as positive, okay. But here positive terminal is first and then negative terminal, so I will take voltage as negative, okay. Or in another way you can say, whatever the terminal which encounters first, you will take its opposite, okay. So I am encountering positive terminal first, so I will take negative, minus of V2, Okay, so that's why I have taken minus of V2, because I am encountering first with positive terminal, then I will negative terminal. After that, if I will reach over here, I will found there is no voltage drop, because these are equipotential points. No element consists of resistance, inductance, capacitance, voltage source, okay, current source. These are called elements. Okay, so there is no elements, then these are equipotential points. Potential difference is zero. If you want to write, you can write, or if you want to avoid, you can avoid. Okay, because writing the zero has none of its significance. So from here, if I will reach here, then I will reach over here. Okay, after this, first I am encountering from this battery source, I am encountering with negative terminal to positive terminal. I am reaching from negative terminal to positive terminal, and with my sign convention, while moving from negative terminal to positive terminal, the battery of source voltage is always taken as positive. In another way, first I am encountering with negative terminal, so I will take its opposite as positive terminal plus V1, and sum of all the, I have reached again to this point, loop has been completed. So what I am saying, sum of all the voltages is equal to 0. So what now I can write is like this. Now it is completely a simple mathematics. Minus IR1 minus, this is only application part. Application part of KVL is just one line. Okay, another thing is only calculation, mathematical calculation. Minus V2 plus V1, it is equal to 0, or you can say if I will just V1 minus V2 is equal to V1 minus V2 is equal to I R1 plus I R2, or we can say V1 minus V2 is equal to I R1 plus R2. Okay, so just this is a mathematical part only. This is just a mathematical part only. Okay, so what I am saying, again I am saying this is the application. This is the application part. Okay, while moving in direction of current, we have to remember these two things. While moving in direction of current, voltage drop IR is always taken as negative. I have taken IR1, and while moving from, I have taken IR1 and IR2 both, because the direction of myself and direction of current both are same. Okay, so I have taken as minus IR1. While moving from negative terminal to positive terminal of battery or source, voltage is always taken as positive. Okay, so while moving from negative terminal to positive terminal, I have taken V1 as positive, and from positive terminal to negative terminal, I have taken V2 as negative, and just I have done this calculation. So this is just the application part. This is more than sufficient for application of Kirchhoff voltage law. If we know these two particular points and we know the statement, we can solve any of the circuit, any of the complex circuits. However, the number of loops may increase, like that the circuit becomes complex, but the basic concepts will remain same for KVL and KCL. So in this lecture, just I have elaborated the very first topic, that is called KVL, Kirchhoff's voltage law, and I hope it should be helpful, very much helpful for you. So just I am just terminating my this lecture over here, and we'll meet in our next lecture. Just we will take another concepts of basic circuit analysis. Thank you very much.